First thing today is a really quick fix. The gas struts that hold the case lid up were not strong enough anymore. I ordered a couple of struts off eBay. I think they were like £14 for the pair, and as you can see, fitted them and they work perfectly. This head here has one of those brushed servo motors on, and we're going to check the depth between the mounting and the top so we can get a step of a similar size. So we've got 48 millimeters, 47.9, 48 millimeters. And the actual motor size is, the back end is square but the center is circular. So the back end is 28, by 28. So in theory we can get a NEMA 11, which is 1.1 inches, which is around 28 millimeters, I believe, to fit in there, which would be great. We may be able to use this existing ribbon. It has got 4 wires. They are grouped together, it's just positive and negative, but it has got 4 wires, and if they're connected separately all the way to the back, it means we can use them for the stepper. Assuming they'll take the current. I presume they will, because this motor takes the current. Okay, right, let's move on to the motor at the back. So this is the Y-axis motor. This is probably going to be a NEMA 17, one of those big jobbies that that's about 60 mil long. So this motor itself is 49.8 mil diameter. I believe a NEMA 17 is 42. Is that right? Or 48? 42 maybe. I'm not sure whether it'll fit with those spacings. Let's see if I can measure the spacings here. They are approximately 28 mil. I don't know. Maybe 28 mil on the NEMA 17. I guess we can look that up. If they were, that would be fantastic, because the NEMA would drop straight in there. Let's have a look to see if we can see. Ah, yeah, okay, so we've got 2 grub screws on there that connect directly to the motor. Hopefully the shaft is the same size. I don't have any spare motors. I stupidly gave all of my spare motors away when I realised I wasn't going to rebuild my other laser before I was gifted this. So with a bit of luck, a NEMA 17 will drop straight in there without any hassle. This, on the other hand, this small one, is going to be a lot more hassle, I think. We'd need to dismantle it to find out. I guess there's no reason why we can't dismantle it. I think we're done with testing, and we're done with the fact that the LCD is not coming back. We're not going to be able to test fire that laser any other way. So let's dismantle it. There we go. I was going to say, if I move it. Right, that looks pretty much like a standard cog. I wonder if that shaft is the same as a NEMA. It'd be fantastic if it was. It's just a little grub screw holding it on. There's our other screw. Okay. So that is, what does that say? There we go. Okay, put that back together, maybe put it on eBay. Somebody might find a use for it. So, that is obviously mounted to a plate. Let's check the offsets on that plate for the screws. They are 21 mil, maybe 20.5, maybe 20 mil. If a NEMA 11 has got 20 mil hole spacings, again, that will save us so much time. I guess we'll see. Okay, so that's out. No going back now. Let's take the back one out, shall we? What are the chances? Yeah. Oh yeah, okay, it went. Oh, look at that. There we go. Okay. You stay there, you come to me. Right, that is unfortunately hardwired on there. I'm going to check the shaft sizes while I'm here and reference them from this video later. That has a circular shaft diameter of 8.1 millimeters. Let's take this off here. Okay. Shaft size on this thing is 4.75 millimeters. That, unfortunately, looks hard pressed into that bearing. I've got a feeling that's not going to come out without a fight. And I could really do with it out unless we are lucky enough to have the NEMA motor mount holes and the shaft be identical to the existing one, and it just drops in place. I think the odds of that are very, very slim, so we might need to press that bearing out. Okay, let's take this bottom motor out. One of these is actually currently listed on eBay in the UK for £200. Now, I'm pretty sure it's been listed for a very long time because nobody wants it. But if I could sell mine for £200, that would go a long way to helping me pay for this rebuild. Okay, there we go. That thing there. It looks pretty monstrous, but I'm pretty sure... Wow, it's got a lot... Oh, okay. It's got a gearbox on it. You can actually feel the gearbox. I was just going to replace it with a normal stepper. Maybe it needs the extra torque. You can get steppers with gearboxes. Oh, that's why it felt loose. It's because the bracket that was holding it in was loose. Oh, okay, yeah, that's the tensioner. Of course it is. Makes sense. Okay, so let's take this off here and measure the shaft. And then, there we go. One cog. We are another random size, 6.44. That's across the widest part, yeah, 6.44. Okay. You can stay there. Right, time to pack up. It's tea time. So while cleaning up and putting it back together, I noticed this plastic strip, which intrigued me. I wasn't really sure what it was for. US Digital Corporation. Does it say? It's just got a serial number on it. It's semi-transparent. I don't think that strip... No idea what that strip does. But if we look in here, we can see that there's some form of sensor that goes either side of it. I thought maybe an optical sensor, but I don't see any breaks in the strip to suggest it detects when it's at the end. I then spent a couple of minutes Googling and talking to ChatGPT. It turns out this is a linear measurement sensor. We were right in thinking it was an optical sensor that goes either side of it. There must be some extremely small markings on it, because the idea is the sensor moves across it and it determines where it is. I think it works a lot like my vernier gauge. As it moves across, it counts tiny, tiny little pulses optically, and that's how it can figure out where it is. We'll have to check this out another day, but I think this is very possibly how The X gantry knows exactly where it is at any one time, which also explains why there doesn't seem to be any form of feedback or measurement on the X gantry motor at all.